Rightio, now we're looking at present value annuities. So this is the second part of the course, and we're going from saving money to have money in the future to having the money now. So all loan questions tend to be present value annuity questions because the lump sum of money exists now. The difference between a future value and a present value is the fact that the lump sum of money is existing now for you. It may be that you have saved up for a long time to have there, but the money that you have to use is now. So it could be a superannuation question or it could be a loan where you've got the money now and you've paid off your house. You need to read the question and make sure when the lump sum exists. Then you need to write down the variables, and the one that you are missing is the one that you've got to find. Same process as before. Typical questions involve loans or calculating how long money will last or superannuation. You need to use your graphics calculator. Make sure when you enter the data that you check CY and PY so that they're the same or they change depending on the question. And make sure you read it so that it is a present value question. So let's have a look at a whole lot of different variations of them. We're going to look at every variable. So you're going to go travel overseas for 2 years and you think that you'll need $800 a month to live on while you're away. So you're going to draw it out of your account. Your account pays you 4% compounding monthly. How much should you deposit in your account before you're leaving on your trip? Okay, this is a present value question because you've got the money now. Then you're going to draw out of it while you're away on your trip. Write down N, I, PV, payment, FE, PY and CY. Just write them down and then you can fill in what you know. So you know that you're away for 2 years, compounding monthly. You've got I, which is 4. Your payment is $800. That's how much money you want to actually draw out all the time. Payments per year are 12, compounding periods per year are 12. You're trying to find out how much money you need now, lump sum of money now, to have in the account so you can draw it out. When you do that, you'll find that your solution is $18,422.60. So you need the money now, present value, to draw the money out over a period of time until you've got none left. Okay, so that's finding PV. Let's have a look at another one. Betty earns $1.5 million from dancing and decides to put into account paying 4.75% compounding monthly. How much can she withdraw from the account each month if she wants it to last 20 years? So the lump sum of money exists now. The 1.5 million is now, so it's got to be a PV question. Okay, so it's got the word compounding in there, so it's got to be a compound kind of question, and it has a series of payments. It's got to be an annuity. Lump sum exists now. It's got to be a present value. So we put it into the calculator. This is just a screen capture from an old calculator. N is 240, 20 times 12. I is 4.75. 1.5 million is your present value, and you'll end up having $9,693.35 is how much she can draw out of the account each month for it to last 20 years, which is pretty good. So that's finding payment. So look at another one. Casey's given $50,000 as a university scholarship. He places this into an account that pays 7.8% compounding weekly. He wants to live on $400 per week. How long will the money last? Okay, mentions the word compounding, so it's got to be some sort of compound question. Mentions a series of payments. Well, it's actually a lot of withdrawals because he gets $400 per week. And the money exists now. The $50,000 exists now, so it's got to be a present value. So you write down N, I, PV, payments per year, all the rest of it, and you put in 7.8% is his rate, 50,000 is his present value, minus 400 is a payment, that's how much he wants to live on each week. Notice that your payments per year are 52, and your compounding periods will be 52 as well, which is not on the screen. You end up with 138.53 months. Oh, weeks, sorry. Weeks. So he lives up for that number of weeks. Scotty, now let's have a look at the last one. Obviously, this is the last rearrangement. Scotty inherits $95,000, invests it in an account paying interest compounding fortnightly. He wants to withdraw $1,600 per fortnight and have the money last 3 years. What interest rate is he looking for, and is it realistic? So, mentions compounding, so it's got to be a compound question. The lump sum of money, the $95,000 exists now, so it's got to be present value. And he's asking for what rate he must get, so it's got to be I. So, finding I, once again, fill it into calculator. N, I, PV, payment, future value, payments per year, compounding periods per year. So the N is going to be fortnightly. So 3 times 26 fortnights in a year. I, you don't know, but the calculator down here has already worked it out for you. PV is 95,000. Payment is $1,600 per fortnight. Payments per year and compounding periods for year 26. So finding rise at 18.9%. Now, is that realistic? No, it's not. You're not going to get an interest rate of 18.9%. So he needs to look at something else. He either needs to reduce the amount of money per fortnight he wants to have, or maybe even reduce the years. It's up to him. He's got to do something to change that around.